is straight to you. Do you know
Yes,
anything
sir.
about current? What is it?
Uh, it's a rate at which electrons flow past a point.
Okay. That is, you mean that mm, d over rate of the dq over dt, right?
Yes.
Where q is, in your case, it's electron. So basically, it's charge, flow of charge, flow of
Charge.
charge through a conductor, right? So let me increase the screen size. Or what is charge? The next question, the first question is that what is charge? What is charge? How the charge is being created? This is one of the important question. How we get charge? How we create charges? How we create charges? Do we know how we can create it? First of all, tell me, can we create the charge?
Yes.
Then how? If
Good
yes, then
evening.
how? Sorry?
Hello, good evening, sir.
Good evening. So how are you, Ridwan? How are you doing today?
Fine, sir.
Did
How
you
are you, sir?
revise? I'm good. Thanks for asking. Did you revise the previous content?
Yes, sir. Yeah.
So my question is that how do we create charges?
Uh,
One of the basic thing is that,
How do we create charges?
yes,
Um,
there are a number of
yes, yes,
ways.
sir.
Huh? If we rub
Yes,
our dry hair with comb, okay,
it creates a charge.
okay, and then bring the small pieces of paper. So what does it do? It attracts papers, right? So what the invisible force over here? Because it's
Yes, sir.
got
Yeah.
positively charged and
Magnet.
paper are neutral, so it's being attracted. So when we rub the comb with our dry hair, the charge gets created. Okay, this is the creation of charge.
Okay, sir.
We may that rub the glass rod on silk. There will be also charges on the glass rod, right? So there's a number of ways from where we can create the charges. And if we have bulk charges, we can just give it a path to it. Suppose it is a uh, any path or pipe, we will just push the charges into it. When there will be some continuous flow of charges, then we will get electricity, right? And then charges will won't flow on itself. We have to provide some force to it. Okay, either we will push or pull. What this push or pull is electric potential. Okay, the push and pull is electric potential. Means that to bring a charge from one reference point to another reference point, we have to apply some work done against the electric field. So this push and pull is that potential difference, right? So Madhya, this introduction is understandable to you?
Yes, sir.
Yes, sir.
Anything you want to add to it?
No, sir.
Okay, when we write dq over dt, it means that your wire is the flow of charge is continuous. Okay, it's not discrete. If this is discrete, this formula doesn't hold. So it's always for the continuous charge distribution. Okay, what is continuous charge distribution? You understand it? Jaslyn, what is continuous charge distribution? Can we expect electricity from a broken wire?
No, sir.
So wire should be always connected, okay?
Yeah.
Yeah, if wire is well connected, we will call it continuous charge carrier. Okay, got the point? So by mean of continuous charge distribution, we mean that there is no break in the wire. If it is like that, this is discrete charge carrier, okay? Discrete charge carrier means it is discrete charges. So this true is hold for continuous charge distribution. Continuous, continuous charge distribution. Okay, Madhya, is good.
Yes, sir.
So how does charge flow? Charge only flow when circuit is complete. We discussed already with in this class. So one basic thing is that what is the unit of charge? Okay, what is the unit of charge? Jaslin and Ridwan, can you tell me how many charges are on one electron? 1.6 into 10 to the power minus 19 Coulomb, right? One electron contains this much of charges, right? When you charge your battery, mobile battery or whatever it is, so you may see that each instant of time, if battery is getting charges, this much electron is flowing through the battery, okay? And being you say that it is charges being stored in the battery. So in theory, if you are charging the battery, you are increasing the weight because electron has mass as well. What is the mass of electron? 6.67. What else? You keep on your mics on. I have no problem with background noise. So electron contains mass as well. So whenever you charge your mobile phone battery, you are increasing its weight. Okay. So we may write it. If we are going to write it, then
Yes, sir.
okay, then I will be written as I is in ampere and this is Coulomb per unit time. Okay, so unit of current is in ampere, and charge we know is Coulomb and T is the time, ampere. So this was the basic introduction, and after that we have to define the potential and potential difference. So Jaslyn, we discussed in length last time about potential and potential difference, right? Ridwan,
Yes, sir.
Ridwan went. I think Ridwan is no more. Ridwan is here. Yeah, of course he's here. So Ridwan, will you brief what is potential differences, potential and potential difference for Madhya?
Sir, can you repeat?
I asked that. I asked Rizwan to brief what is potential and potential difference. Madhya, can you tell me what is potential instead of Ridwan? What is potential and potential difference?
It is the energy that is stored.
You are talking about the potential?
Yes.
Okay, potential. Potential, electric potential, right? Electric potential, you may say that is the energy. Okay. See, if we want to connect a circuit, we have to flow the charges. Okay, we have to bring a charge from some another point to a given point, right? Then only the current will constitute in the circuit. If we are not able to route the charge from a given point to another given point, we won't be getting electricity. What is the mechanism? If this is the bulb and this is potential battery, so we have to drive the charges from to complete the circuit from this terminal to all the way to this terminal, right? Then only we will get current, right? So it's being said that to bring a charge from, we may fix the point at the infinity. What today? Ridwan, sir, my network is bad today. No problem. So you just stick over here. Okay. So we say that to bring a charge from infinity. Infinity is not infinity, but some large distance. From infinity to a given point of, to a given reference point, we have to do some work against the electric field. Okay. So that's the amount of work done needed to move a unit charge from reference to a specific point against the electric field is called electric potential. Got the point? Jaslyn, did you understand it?
Yes, sir.
It's clear?
Yes, sir.
Madhya, to you?
Yes, sir.
So did you, this is called the accommodation of concepts. So your earlier concept and what I discussed, those resembles or have some different differences. The thing what I was say, I said that you think the same, or is the difference?
It's same, sir.
Okay, so this is the definition I got from some sources. So the another thing is, Jaslyn, just bear with me because Madhya is new, so we have to repeat little bit some concepts. What is potential difference? Jaslyn, could you tell me what is potential difference? Jaslyn, could you tell me what is potential difference?
It is work. It is the amount of work done for positive charge particles to move from one point to another.
Ah,
Exactly.
that's somehow electric potential, not the potential difference. So potential difference is that we always see the torch as cell being used in torch. Okay, so this is a zinc over there, or there is one tip. Okay, so this is the tip. This is the battery. Here is positive charge, and here is negative charge. So if you will read the wrapper on the battery, you will find that it is written somehow 1.5 volt. Okay, so means that the potential difference between these 2 points is 1.5 volt, right? So this is necessary to drive the current. Okay, this is the mechanism, or you can say the driving force which drag the current electron from one point to another point in the circuit. So this the difference between these two potential, these 2 points is said to be the potential difference. Madhya,
Yes, sir.
so it's clear what is potential difference?
Yes, sir.
So if it's clear, then we can define this work done. That is W is equal to charge into potential difference. If we are bringing one charge from this potential to this point, okay, so we have to multiply the charges with the potential difference, right? The charge is we are bringing from here. As the potential will be higher, that work done will be more and more, right? That's why if we touch 12 volt terminal, we get very small shock. But when we touch 100 or 220 volt supply in our home, we really feel it, right?
Yes,
If
sir.
we will touch 1000 volt, 10,000 volt, then it's the last day of our life. We can survive up to a few voltage as well. So this is the work done equation. W is equal to VQ. And we know all the quantity work done. What is the unit of work done? We calculate work done in joule, right? charge in Coulomb, potential is potential. That is VQ. So should we proceed further? It was not too fast.
No, sir.
Okay, so I think we have left with some introduction. Then electric potential difference named after Alessandro Voltas. Okay, he lived in this time, 1745 to 1827. He was an Italian physicist, and 1 volt potential difference between 2 points in a current carrying conductor when 1 joule of work is done to move a 1 coulomb of charge from one point to another point. This is definition of 1 volt. What is the 1 volt? If you have unit coulomb charge, unit matlab 1 coulomb charge, 1 coulomb charge, and you do 1 joule of work, right? So to do this work, you need at least 1 volt, yeah, or unit volt potential difference. So you may write it down. What is 1 volt? Okay, Madhya, will you note it down?
Which one, sir?
Definition of 1 volt
Okay, sir.
from here to here. If you feel any disconnection in thought or concept, you may ask me.
Okay, sir.
Okay. So, Jaslyn, are you aware of components of electric circuits and its symbols? Do you remember everything?
Yes, sir.
So I think it will be not good to repeat with you. Or should we do? Should we repeat it again so Madhya can understand a little bit?
We'll do it again, sir.
Sorry?
We'll do it again.
Will you type in message box? Madhya, when you are done, please let me know. Okay. We'll do a little bit faster, okay? Because Jaslyn already studied. So Madhya, it will be little faster. Whenever you feel any difficulty, you may ask. So how we measure the potential? It is being measured by an instrument called voltmeter. Okay. So how we use voltmeter? We use voltmeter across the terminal. So if we have one load over here, so how we will use it? This is battery or something. So here will be a potential drop A. If this is bulb, and there will be potential drop between these two. So we have to utilize the voltmeter across this point to measure the numerical value of potential difference. We all have seen the voltmeter in our daily life. Okay. Any electrical instrument, you may have seen this. So now we have a short example. We say that is numerical. How much work is done in moving 2 coulomb of charge across the potential difference of 12 volt? Madhya and Jaslyn. Ridwan as well. We all did this problem, right?
Yes, sir.
So Madhya, can you do this? Madhya, are you there?
Yes, sir.
Can you solve this problem?
I will try, sir.
Okay. So in between, so we already know that W, that work done in bringing a charge from one point to another point, from say A to B, when potential difference is 12 volt, that will be equal to Q into V. So V is already 12 volt and charge is 2 coulomb. So it will be 24 V into C, volt and coulomb. So work done will be 24 joule, right? Got the point?
Yes,
Unit of
sir.
unit of work done is joule. Okay, so that's why V into C comes like that. So the next concept is we see always in electricity that it is made up of some components. Either it's resistance, some cell or batteries, sometimes some capacitance as well. This is the cell, this is the battery, this is the capacitor, this is the battery, this is the capacitor, and there are in number of other things as well. So what is use of all these? Okay, we have to brief it. Okay, what is electric circuit? A circuit diagram is a graphical representation of an electric circuit. Okay, a pictorial circuit diagram uses simple images of component, while a schematic diagram shows the components and interconnections. Okay, so we will be showing over here the schematic diagrams of the circuit using a standardized symbol representation. So the focus of this introduction is that we have to be familiar with the standardized symbols. So if we have to show a battery or cell, cell is C, the cell is the unit combinations, and battery is the combination of cells, right? So this is the difference. So the longer hand is positive charge and shorter is negative charge. So we connect positive of one to negative of other, okay? And then positive of one to the negative of other. In this way, we used to connect our cells. So it's being shown over here. So you have to see the switch. Okay. So switch is like that. If switch is open, there is no hole. If it's on, then there will be hole. Wire joint is being shown by this. Suppose this there is one wire. If we have to connect another wire, then we tie the another wire over here and then we take it out. So this symbol is like that. If we don't want to, we want to cross two wires on some junction and we don't want to touch one another, so we show it like this. If we will put like this, then there will be short circuit over here. If we want to avoid the short circuit, we have to use this symbol. Clear? We are a little bit fast. So there is a standard symbol for bulb. Okay, we can use this symbol to show the bulb. This resistance for this is only for resistance. Okay, if you are showing it like this, if you are trying to show it like this, any resistance, this will be wrong. This is something other called inductance. Okay, so this has the another symbol. This is different from resistance. And the next one, I think it's being little bit out of that. So we use this symbol for resistance. If we have variable resistance, if we want to vary the resistance in between our calculation or reading, so we have to use some symbol like this. This, either one arrow, this shows that this is variable resistance. Even if we want to show the variable current source or voltage source, we may use like this. Right? V over here, and you make like show it like that is the variable. Okay. So this was the introductory part. Now we have to move a bit faster. These are the questions. Name the device that helps to maintain the potential across a conductor. Jaslin, Madiha, and what the another one? Ridwan. Do you remember this? What is the device which helps to maintain potential difference across a conductor? Which device we use?
Battery and cell.
Okay, good. So it was Madhya. What is meant by saying the potential difference between 2 point is 1 volt? What does it mean? Potential difference between 2 point is 1 volt. So you may define it in the terms of work done. Okay.
Okay, sir.
So go and read the text. I already explained it. Go and read the text and then solve these problems. How much energy is given to each coulomb of charge passing through a battery of 6 volt? Here, here is each coulombs. How much energy given to this? So we have a battery of 6 volt. Then how much work we have to do? Jaslyn, we did this yesterday with the last class. Do you remember anything?
Yes, sir, we did this question.
So how we did that? This is the charge, right?
Yes, sir.
And this battery potential is already 6. We did the problem now, that 2 volt
Yes.
and 12 and 2 coulomb and 20. So here is given, we may let it, this is electron. So electron is, Madhya, what the charge on 1 electron? This is charge on 1 coulomb, 1 unit of electrons, right? So you may consider the coulomb charge, and then we have the battery, so we can take the work done V into Q, right?
Yes, sir.
So Madhya, do you remember what was the Ohm's law? German physicist in 1827, George Simon Ohm, he found a relationship between applied voltage and the current. Applied voltage and the current. So he found that V applied voltage, as we will increase the voltage, the current will change. Is the V is directly proportional to I. Is the direct proportionality. So if we will remove that proportionality, we have to introduce one constant, then this is comes to be V is equal to Ri. Is the simple one, right? This is true for ohmic objects. Ohmic. OH, OH, M, IC, ohmic materials. Ohm's law is only valid in the ohmic materials. Why it's being said that temperature remains constant? If you will change the temperature, the ohmic nature of material will change. Okay, so we have to keep the temperature throughout constant. Then only this formula will be valid. So it is very known formula, equation of straight line. Have you read about it? in linear equation in two variables?
Yes, sir.
So how, if we want to plot V versus I, how it will look like? Linear, of course.
Yes.
So if I will try to draw it, in which axis you wanna put the voltage and which axis you wanna put the current? Which one is independent? So if you put the current on the x-axis and voltage on the y-axis, then this is the y is equal to mx. So this is similar to x-axis and this is similar to y-axis. Substituting v on the y-axis and I on the x-axis, right? Any confusion? Any confusion or everything is okay?
Yes.
Is okay? Quick, there is no confusion.
No, sir.
So if we will draw it, it will go straight. If you see that relation between V and I is a straight line, you may say that, or you must have to say that this material is ohmic materials, okay? Like copper, aluminums or something, metals, conducting metals. When we come to the semiconductors, those are not ohmic, okay? So you may somewhere have to keep in the mind what is ohmic material, non-ohmic materials. It's clear? The next thing is factor. This is now that R plays a very crucial role. If you will take the V over I, V over I. If you will take the ratio, what you will get? If you will take the slope of this ratio, what you will get? This is the V and this is the Y. I. Delta V over delta I. So, Jaslyn, if we take the ratio of V over I, what we will get? Tell me what we will get. Madhya, if we take the ratio of change in velocity, change in voltage divided by change in current, what we will get? Do you know the motion in uniform motion? Uniform motion.
Yes, sir.
What is uniform motion? Can you have the definition? Equal displacement in equal time interval, right?
Yes.
Means that if you will take the ratio of equal distance, equal time, delta t, delta d over delta t, you will get a constant value that is uniform velocity, right? And it will be always constant. The two consecutive slope and two consecutive distance, two consecutive slope. It will always come a uniform. Uniform means that velocity will never change. It will remain constant. Constant. So what is this R? This is also constant, right?
Yes.
So if you take the ratio of these two along this path, you will always get a constant value. You may check if we take this point, another point. If it's a straight line, it's still a straight line, you take another slope. Okay, another slope. Delta V over delta I. You will you may draw it on graph paper and check what is the results. Jaslyn, it's bit. I think this is the addition from last day class. Okay.
Yes, sir.
So this is the slope. You know one thing more. These are the very interesting thing. We know the circumference of circle is c is equal to 2 pi r, right? If we will take the ratio of c over r, take the 2 as well. This is the d. We mean like pi into d. So if we will take c over d, ratio of c over d, it will come pi always. This is constant. So how the earlier scientists discovered the value of pi? This was the measurement. They measured the circumference of given circle divided by the distance or diameter. They always found a constant value that was very much real, 3.142, and that they named it pi. Got the point? So now, what factor does the factors which resistance depend upon? This simply R depends upon, R is proportional to the length of the wire. Suppose this is the wire, okay, and it has a length L, so it will depend upon the length. And if it has a cross section means its thickness, then it will be reciprocal to area of cross section. R is the length of wire, and A is area of cross section. You know area of cross section? What is area of cross section? What is area of cross section? Madhiya or Jaslin? What is area of cross section? Vidwan, what is area of cross section?
The area of two-dimensional
Area of dimensional
shape.
means that this is our wire, okay, or whatever it is. So if we will cut it through some points, okay, perpendicularly, so it will be like a circle in this case. So this is the area of cross section. If we cut it in some other shape like this, okay, so this is not perpendicular to the surface, so it is different from area of cross sectional area. Okay, so in this case we will cross sectional area, and for the wire it will be equal to pi times radius square. So the resistance depend on the length of the wire and reciprocal to the area of cross section. So R is given as constant of proportionality is rho L over. Clear?
Yes.
So it also depend upon the materials as well and on the temperature. So we have some material at a constant temperature 20 degrees C. For conductor, we see that resistivity is of order of 10 to the power 6 to 8. For alloy is minus 10 to the power 6. And for insulators, it's 10 in positive 10 to the power 12 to 10 to the power 14. Okay. So alloy is in between of conductors and insulator, right? So if we see the silver is 1.6 and 10 to the power 8. So that's why if you will use silver in conducting wire, you will have the seamless of current supply. So in some sensitive materials or in expensive mobile phones, silver is being used. Most of the household use copper. Is cheaper as well, but there is no much difference in its resistivity. So what is resistivity? Resistance, can I ask what is resistance? I forget to ask this. What is resistance? Can you define what is resistance? Resistance actually opposes the flow of current. If you will ask an exam to read it, how you will define it? Jaslyn, how will you define it if someone asks what is resistance? Okay. Okay, it stops electricity. It's not a stops actually. A stops means that you are just putting some force and you are stopping the flow. It's resist the flow. Okay, it's resist the flow. How? Why there is resistance? If charges moves from one point to another point, it faces collision between electrons. That collision give rise to resistance as well as the heats. Okay, so it's resist the flow of current through a circuit. Madiha, is clear to you?
Yes, sir.
And Jaslyn and Ridwan, from here we are starting the new points. Okay, so how the alloys are being made, you have to keep in mind how the constantine is made up of copper and nickel. This may be asked in your exams. Magnesium is made up of copper, magnesium, and nickels. Nichrome is nickel, chromium, magnesium, and iron. Nichrome is widely used in filament of electric bulbs. This bulb used to come in early days. Remember? Not in LED or something. LED and tube lights. It were in early days the yellow light, yellow bulb. Remember? Yellow bulb. We're having some tungstens. Have you seen such bulb in your life? Have you seen such bulb in your life? Yes, sir. Okay. Rizwan have seen it, but I think Jaslyn and Madia is not that much older. Madia, have you seen such bulb?
Yes, sir.
Okay, so we all have seen. Okay, so now I have said that this is the taken reveals that from table this reveal that resistivity of alloy is generally higher than the its constituents materials. Okay, when we mix two or more than two type of material, we form alloy. Alloy has resistivity has the reveals that resistivity of alloy is greater than that of constituent material. Alloy do not oxidize or burn readily at high temperatures. For this reason, they are commonly used in electric heating device. Alloy are being used in electric heating device like electric iron, toasters. Tungsten is almost exclusively for the filament of electric bulbs, whereas copper and aluminum are generally used for electric transmission lines. So these are the uses of some materials. And you may say that some of the devices are being made of such materials. Okay, it's clear? Jaslyn and Ridwan, it is bit fast, but is it still
Yes, sir.
clear?
Yes,
Madia,
sir.
is clear to you?
Yes, sir.
Any doubts?
No, sir.
Any question? If no, then I have a question for you. These are based on the Ohm's law, right? Madiha, Jaslin, and Rizwan. I'm giving you hints. How much current will flow through through an electric bulb? So the given part is we have to find the current from a 220 volt source. The V is 220 volt. If the resistance of bulb filament is 200 ohms, 1 2 ohms. So can you find the current? We have to use the Ohm's law. Ohm's law. That V is equal to IR. Now it's easy, na? Madia, are you able to find?
Yes, sir.
Jaslin and Ridwan both. Yes. So do it. Ridwan and Madia, do it and show it to me. Hmm. Any progress? Jaslin, any progress? Ridwan, any progress? It is 5. It's 45. It's Ridwan. So, Madiha, what's your answer?
0.18.
So 0.18. So we have to find I. So we have this relation. So it will be simply I is equal to V over R. What is your response, Jaslyn? That's this one only 10210. And then it will be 2 say 11 and 2 say 60 time, right? Then it is almost 1 over 11 over 60. So this will be almost 1 over 5. 1 by 5. So it is order of 10 to like that. Anyone get the answer like this? What is your Madhya? What is your answer? Ridwan said 4-5. I don't agree with him. And Rizwan says 0 again. So what is Madhya? How did you solve it? So you didn't get 0.25. Yeah, of course. So I got 0.25. I did bit approximation. Okay. 11 5s are 55. So it was 60. So just I rounded off. Okay. So if you got this answer, could you try how much current will an electric heater will draw if we have 220-volt source if the resistance of coil is this? This time again we have to solve how much current will an electric heater coil will draw. So the same Ohm's law we have to use, right? Okay, if you have successfully solved this question, then the next question for you is this. Potential difference between terminal of electric heater is 60 volts. So V is given at 60. It draws the current of 4 ampere. 4 ampere. What current will heater draw if potential is increased to 122 volts? So with this information, what we can find? Madhya?
Yes, sir.
V and I is given. So what can we calculate from this? What unknown results? V is equal to IR.
Yes, sir.
R is unknown. So we can find the R from here. If once we get R, then the current is in second part, current is being asked if the potential is increased to 120 volt, right? From 60 to 120 volt. So we have to find the current. What current will the heater draw? We have to find the current if V is changed to 120 volt. So we know already the resistance, then I is equal to V is equal to IR, V is equal to IR. So I will be equal to V over R, right? So we have 120 already we calculate and we will calculating the R from the earlier relation. So if we will do like that, we will be getting the solution of this question, right? But it is unjust to you that I solved that question. So the next question you have this one. And you have to do it all alone. Will you do it? Jaslin, Ridwan, Madiha, will you do it?
Yes, sir.
So it's the post-session question. Okay. So you solve it and I'll be sending you more numericals. So we will be meeting the next day. We will be starting with the numericals. Concept is clear to each and everyone, including Madiha and Ridwan, Jaslin. Oh, I took the name of each and everyone.